Alrighty. So pretty much today we learn about limits at infinity. So what I want to go ahead and show you is the following. Um, the first way is to think about it like as end behavior. I know we were mentioning it earlier, or the interval notation, but that works as well. So you want to think about as x goes to infinity, the y values, right? The y values themselves are going up, 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 because this one's linear, and it's going to infinity also, right? Or we know how to substitute, right? Because we learned how to find limits using direct substitution. So if it's telling me that x goes to infinity, right? X goes to infinity, then you go ahead and substitute that right here. So our answer should be infinity also. Whichever one you do is perfectly fine with me. Let's try it again with this different example. And it says the limit as x approaches infinity, right? As x approaches infinity. So this way, what is the y doing? What is the f of x doing? What is this function doing? We can go ahead and see that it's going up, 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 up. So what is this value going to do? It's also going to go to infinity, right? So the limit will also be infinity as x goes to infinity. And you can do the same thing. You can go ahead and substitute this infinity squared. I don't know what that is, but I know it's going to be a very, very, very large number. We're going to say it's also infinity. Does that make sense? So it's up to you, honestly. You can go ahead and think about the parent function, or you can just do direct substitution. They both work. And we learned both of them, right? Any questions so far? I do have a little bit of definitions here. I'm sorry, notes. So this right here, you can go ahead and write it down. And pretty much I want you to think as this number gets really, really large, what's going to happen to my function as that number goes to infinity? Well, remember my pizza example? If I have one pizza divided by all the people in the world and all the, I don't know, everyone, right? What's going to happen to my pizza as x approaches infinity? What's going to happen to my pizza if I have a pizza? Eventually my pizza will become 0, right? So that's what this makes sense. And it doesn't matter if it's going to positive infinity or negative infinity. If the number is larger in the denominator, this will always be 0. And hopefully it makes sense because you're trying to share one item for almost infinity people. I know it doesn't make much sense when it's negative infinity, right? You're trying to share pizza with negative infinity people, but the idea is the same. The number is very, very large on the denominator. I'll give you a couple more seconds to write that down. I guess I got to practice from the YouTube channel. This would be like where you pause the video, guys, and write it down, right? Okay, can I continue this? Okay, if not, they're on the PowerPoint, guys. I usually post the PowerPoints the night before, so you guys can write them down. Alrighty, so let's go ahead and try this. So I got this example right here, and we're doing the same thing as x approaches infinity. So here, 4 stays the same, right? Because nothing was affected to my 4, minus my 3 as x goes to infinity. So what can we say about this fraction right here? What's going to happen here? My 3 is being divided by a very, 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 very large number that we can say it's infinity. What can we say about this fraction right here?
Equal to 0, you said?
Yep, because of the notes before, it's going to go ahead and equal to 0. So it's just going to be 4 as our limit because all of this goes to 0 because division, you divide it by infinity, right? Let's pretend this was negative infinity. Let's try the next example. The 13 divided by x going to negative infinity plus 14. Guess what, guys? It's the same exact thing. This right here still goes to 0 because division of large number. So our answer is just 14 here. Any questions so far? Yes, no?
Real quick, what does L represent again?
The limit.
Okay.
Yes, sir, I do have a question.
Yes, what's up?
Wait, why is it negative infinity on this
Oh,
one?
I'm sorry. I just wanted to show you that it works for both.
Okay.
Works for both positive or negative. Sorry, I should have said that. Both.
Wait, I'm actually kind of confused. Why is it 14?
So all of this right here, this entire fraction is divided by x, right? And my x is going to an infinity. So like, remember from class, I would say the pizza. My pizza, if I share it with you, we get a pretty good size of pizza. If I share it with all 23 people on the chat, there is like, we get smaller. And if I share it with all of Texas, all the whole school, I'm sorry, with.
Oh, basically because it's so small that when you just have the plus 14, that's basically what you're gonna get.
Yes, because the 14 is not getting affected by anything.
Okay, I get you. Thanks.
Yeah. Any other questions, guys? No. And so this works for both positive infinity or negative infinity. But like my pizza example doesn't work as much with negative people. Negative infinity people. Okay, so this right here is how to find horizontal asymptotes with infinities. Believe me or not, this happens a lot throughout the calculus course. So go ahead and write these down, even if you decide to take stats next year. Let's go ahead and talk about this real quick. So this right here is the first case when it is bigger in the bottom, right? We just talked about it when Q is bigger in the bottom. Like my pizza gets shared with so many people that the limit becomes 0, right? The limit becomes 0. So that we just did. This one is talking about the degrees. The degree, and this is the one we're going to do in the following examples. So I know these are like a little weird, but it's not that bad. So if the degree of the function p of x is the same as the degree of the function here, all we need to know, guys, is that pretty much x cubed over x cubed or whatever the case may be, and let's say this is a and this is b, these right here are both increasing at the same time and they're the same thing. So eventually they'll reach infinities together at the same time. I know it sounds super weird, but pretty much what I want you to know is you can go ahead and what you guys like to call is cancel. But pretty much they rise at the same rate. And eventually they'll reach y equals a over b. And this one right here, what if it's bigger in the numerator? So pretty much your pizzas are infinitely many versus the small amount of ants or whatever. It's going to go ahead and go to infinity. If it's going to infinity, if it's going to go to negative infinity, then will it go to negative? So pretty much x to the 5th divided by x, you can see that it's bigger in the numerator than in the denominator. So this will probably go to infinity if x is going to positive infinity. Does that make sense, kind of? If not, I got examples and we'll do it right now. So pretty much the first one, I'll give you a couple seconds to write it out, but they're not that bad, promise you. So the first one, as x goes to infinity, well, we can notice that it's negative 4x squared on the numerator and 2x squared in the denominator. So all I want to look at x with the largest exponent, right? Everything else, guys, you can pretty much ignore it. So all of this right here, we're not going to take a look at it. So it's just going to be negative 4x squared over 2x squared. Because these are pretty much going to determine what is your parent function, how's the function behaving, and whatnot. So as these numbers, this x squared and this x squared, if I see that they're the same, right? P of x is equal to q of x. It said all I need to care about is my a over b, which in this case, my a is on the top, my b is in the denominator. So it's negative 4 over 2, which is just negative 2. Limit will be negative 2. So if you graph this, guys, on a calculator, you put all of this into Desmos, the graph will go ahead and converge to negative 2 on this. So it would be something like a little graph that goes to negative 2, something like that. And it'll just go negative 2 as a horizontal asymptote, like that. It's pretty cool. Okay, any questions on that? Pretty much I'm just using these rules right here. Okay, can you guys, by seeing this, hopefully understand that what will be the answer? What does it look like? If they're both x to the second and x to the second.
Just 3 halves.
Yep. Yeah, so this right here, we don't have to worry about it because you're going to infinity. These are little smaller infinities and these are bigger infinities. Super weird stuff, right? So pretty much p of x is equal to g of x once more time. And I got that this will be 3 over 2 for my limit or my y value, right? My height as x approaches infinity. Any questions, guys?
So we're just focusing like on the first exponents, right?
Not quite. So you're focusing on the x with the largest exponent. For
Okay.
my calculus kids, if this was a normal class, I usually on purpose, I put this 2x squared in the very back. Like I just, yeah, it's just, but that was just to like make sure, like had them on check. But it's the x with the largest exponent. So pretty much on this one was this one and this one was this one. I don't think I tried to trick you guys this time though. Any questions, guys? No? All right, let's go ahead and do 2 more examples. So go ahead and do this one on your own. And you can put the answer in the chat box if you want. Watch out, this one I did try to trick you guys. I'll open up the chat in case you guys need to put the answer there. Yeah. So hopefully I didn't trick you guys that bad. Oops. Hopefully I didn't trick you guys that bad. But the largest exponent in the numerator is this one right here, negative 4x squared. And the largest in the denominator is this one right here, 9x squared. So on the numerator, because my p of x is equal to the q of x, all I have to do is that the limit is a over b. In this case, this is my A, this is my B. So I got negative 4x squared is divided by 9x squared. So we can see that the degrees are the same, right? And it's negative 4 over 9. That's my limit. Fun fact, you keep this right here, this sign, whatever sign's attached to it, you keep it. This actually has a plus sign, so it's positive. Any questions, guys? No? This is fun. Negative infinity. Ooh. What's that gonna do? Regardless, you do this exact same procedure. So you look at the biggest one on the numerator, which appears to be x cubed, right? X cubed. And the largest one here in the denominator is negative 10x squared. Okay. As x goes to negative infinity, sorry about that, negative infinity, what's going to happen? Well, it's rising a lot faster in my, well, on my numerator. So just by this definition, it should be an infinity, a positive or negative infinity, right? So we're gonna go ahead and check. Oops, oops. So we got this right here. We're gonna substitute this negative, right? This right here gives me a negative, right? Because negative times negative times negative, so it's negative. And this right here is negative also. So this is gonna determine the sign, if it's positive or negative. So at the end of the day, this will be positive infinity. So the limit will be infinity. So this one was a little tougher, but because it was larger on my numerator, right? This was bigger. This was the rise faster, right? Then
Wait.
my denominator, it will be going to infinity.
Wait. I was not negative infinity.
So the negative was right here, Daniela, and negative cubed, negative times negative is still negative on my numerator. My
Oh,
denominator.
wait, you substituted in for the x, right? That's why?
Yes.
Oh, okay. Oh, I
So
forgot
I
that.
got negative infinity, and then in the denominator, it's just x squared. So it still kept it positive, right? Because negative times negative is positive, but it had a little minus sign, so I kept the minus sign of the 10. So I kept the positive infinity. Or what my students like to do, they said x cubed. Oh, that's x times x times x divided by my negative 10x squared, which is a negative 10x x, and they just got rid of these right here. So they did this, and it was just x over negative 10 as x goes to negative infinity, sorry. So they went negative infinity on the numerator over negative number, which still gave them the positive infinity. That's what they like to do, which gave them the same answer. So I was okay with it. Any questions, guys?
No.
That is all I have, guys. This is gonna be due on May 3rd, which I believe is on Monday at 3. Stop.